should be this. Okay, area bounded by the curve y equal to fx, an interval of x between a and b and the x-axis. Yeah. So why must I know area bounded by a curve? Why must I know area bounded by a curve? What am I trying to find? Have you in your physics, you learn to find area bounded by a curve and it represents something? Can you tell me what curve is that? Yes. So velocity time graph. So if I give you a velocity time graph like that, I want you to find, so what does this area represent? So this area represents total distance travel in the first three. Why this area represent total distance travel in the first 3 seconds? Why this area represent total distance travel in 3 seconds? I'm asking you why. So you have to give me a reason. Why? Okay. Yes, because it's right. Because if you want to find the area, because when you find the area, you are taking velocity times time. Right? Am I right? Velocity times time give you the displacement. Am I right? So that means in life, not every function, the area means something. Am I right? If I give you a displacement function curve, then the area means nothing. So far, anyone define a function, a quantity, a physical quantity that represent displacement times time? No. Am I right? So you have to bear in mind. So my next question will be, what is the relationship between displacement and velocity? Hey, you are learning differentiation net. How can you tell me velocity is displacement divided by time? That is constant velocity. Correct. So the rate of change of displacement is velocity. All right. So my Vt is equal to S prime T. Am I right? Okay. So so you know that, okay, total distance travel in the first 3 seconds. Okay, is the area bounded by the velocity time graph. Am I right? Yes? Okay. So you understand this idea? So now, if I give you any function and I tell you this is y equal to f prime x, then you tell me what does this area represent? In words. In words. So this is called a general statement. This is a specific for velocity. So how are you going to put it as a general statement? Put in rate, important. It's a rate of change graph for fx. You are given the rate of change graph for fx. Like this one, I can say this is s prime t. So now I want you to, from specific statement, give a general statement. Faster. You are able to. Area bounded by the rate of change curve. That is y equal to f prime x. For x between a and b and the x-axis represent what? Represent what? Total amount of what? Total amount of what? This is ST, right? Total amount of what? Fx within this interval. Right? So you have to be very careful. The graph I give you, what graph is that? And how can you interpret from the graph? Does the area of that graph mean certain thing? If it's this graph, then it means this. Correct? So that is the first thing that you have to bear in mind. Okay, that is the first concept. So for your SAT, for everyone, you have to be very careful. What graph do I give you? Yeah. Total amount of fx, like this one is total distance or total displacement. I'm making a general statement. So I don't know what is my fx. So fx, I can be say rate of change of the number of animals. If you study biology. So what is the total number of animal produced within this time period? Then you find the area bounded by the curve of the rate of change curve. Are you clear? So that is the core of this chapter. When you come to application, the part. So you have to bear that in mind. Not all the area means something. If I give you the rate of change curve, then the area means this. So bear that in mind. Can or not? Okay, now, how are we going to find the area? Like for example, okay, let's go to now, how to find the area now. If it's a curve, how to find the area? Okay, now, if for this case, I ask you to find the total distance traveled in the first 3 seconds, correct? You should be able to do it for me, am I right? Hold on. Okay, so this is a velocity, this is a time graph, right? So I say find the total distance, right? Traveled in the first 3 seconds. No problem, am I right? Can you find? It is a straight line, can you find? Okay, someone give me the answer. So total distance? 13.5 is the area of the trapezium, correct? The width is 3. The height here is 5. This one is 2. So the area of a trapezium, sum of the parallel side times by the width divided by 2. Correct? So it's 10.5. Am I right? Regular shape, you can find the area by using the formula. But if you look at the example that I give you in the times there, correct? Do you see that? Okay, in times I got give you this, correct? Okay, I got give you a velocity function, and I got give you the curve go like that, correct? And the velocity function is Vt is equal to 2e to the power negative t plus 2. Correct? So now if I ask you to find the total distance, find the total distance traveled in the first 4 seconds. Means here. Am I right? So which means that I have to find area bounded by the curve y equal to 2e to the power negative t plus 2. Correct? Some more? So this is the first boundary. The first boundary here. Where are the other boundary? Straight line. So straight line. There are 3 straight lines. Straight lines. X equal to 4. X equal to. So this is the second one. X equal to 0. This is the third one. So when you want to talk about area, it must be enclosed. So where is another straight line? And, okay, I should put T instead of X for this situation, am I right? And T axis. Am I right? So this is the fourth one. So you see, please don't talk in class. If you disturb me, you disturb the whole lesson. Thank you. Okay. So you see, when you want to find the area, the shape must be enclosed. But this is not a polygon. If it's not a polygon, how are you going to find the area bounded by the curve? How are you going to find this area? Some of you all will tell me integration. I will ask you, why should I use integration? Because my teacher says so. I don't accept that. How come this can be lead to integration? I will ask question like that. I will ask my teacher until she dropped. Okay, so I'm asking on behalf of you. Okay, so now I cannot do it. But if I ask you, can you give me an estimation of this area? Anyone in the class, can you give me the estimation of this area? Anyone? Can you give me an estimation, please? And you tell me how you get this estimation. Hurry up, take out your calculator and give me an estimation quick. Hello, use your brain. You give me a value, then I will explain to the class. 10. Okay, you say 10, huh? Okay, you tell me how you get 10. No, when people ask you, correct, your estimation, correct, you must say there is a way to estimate. You cannot just say, simply say, no such thing. In maths, there is no such thing as simply say. There is a rule, there is a way to do it. Okay, give me the estimation. If you can't explain to me, I don't accept this. Okay, just tell me an estimation, then tell me how you get the estimation. So 10 don't accept because you cannot tell me a reason how you get the value 10. A formula of parallelogram, that means, okay, then you tell me what time what, you give me 10. Then I will explain to the class. I will draw the diagram. Okay, 3 plus 2. 3 plus 2 times 4 divided by 2. Okay. Can you tell me how you get the 3, how you get the 2? No, the number of the diagram that is, I'm talking about line number 3. I'm not talking about this length is 3. Hello, I'm not talking about this length is 2. Apa cerita ni? Do you see I put a circle? If I want to tell you is the length, I will draw like that. Ha. So that is wrong. Okay, now they start to calculate. They simply take the number as they like. The equation for this one is y equal to Vt is equal to 2e to the power negative t plus 2. Okay, you use, instead of use trapezium, you try to use a rectangle and give me the estimation. Okay, now I give you hint. Give me the estimation by using rectangles. Cannot say below 20, how you get the 20, you tell me? Okay, 5 times 4. Okay, why you take 5? Okay, if you say like that, I will ask you, why don't you take 4 instead of take 5? This point, the x is 0. So 0, the y will be 2e to the power 0 plus 2, which is 4. Why you want to take 5 here? That make the estimation way out. So you want to take 4 or take 5? Why you take 4.5? Okay, so this is not a good estimation. If you look at the diagram, my good estimation will be 4 times 4. So that's why I want to do discussion. I don't want to give you the answer. That is 16. Wait, I'm talking about rectangles. So now when I say, listen here, 4 times 4. That's why Malaysian students don't know how to do estimation. Their estimation is very low, yeah. Okay, look, when I say 4 times 4, I'm talking about a rectangle of the height 4 and the width is 4. Right? So I draw this rectangle. Am I right? Am I right? So you tell me, hello. This estimation is an overestimation or an underestimation of whatever we want to find. Why is it over? Because it covers an extra part up there. Am I right? So this is called the overestimation. Hello? Got it? I'm not saying wrong. It's better than I don't know what to do. Am I right? So now I know that my area will be less than 16. So that means I will know that the total distance traveled will be less than 16 meters instead of sitting there and do nothing. You keep saying the marks, young man. Yes. Okay, can someone give me an underestimate? Can someone give me an underestimate? Divide by 2, you cannot judge. If you say this divide by 2, I cannot judge. How you know that is underestimate? How you know the straight line 4 joint? Okay, can. That can be an underestimate. Okay, we try to stick to an can. Your friend said this underestimate can. That one I'm not saying cannot. Hello. From the 4, you draw a triangle here. Can. To here. So this is 4. This is 4. Can. So they can be an underestimate. But if I use a rectangle, then how? This is an underestimate. So it's half of 4 times 4. So that is 8. Can. This can be an underestimate. So that means the area bounded by this curve, the total distance traveled will be, based on our understanding here, it will be between 8 and 16. So sometimes question also can come out like that. Okay, tell me why the total distance traveled is between 8 and 16. So you have to explain how you get 16, how you get 8. So these are called estimation. Okay, so now, done? Okay, can I move to the next one? Good. So now I have a question for you. How to use rectangles how to use rectangles of equal width to make a better approximation. Okay, how are you going to make a better approximation? So now, okay, I want you to, for this curve, okay, divide t between 0 and 4 into 2 rectangles of equal width. And find the sum of the area of these 2 rectangles. To make an overestimation. Of the area bounded by the curve. I don't write all already. Okay. So look, I have the interval. Very important. And I say equal width. Why must I mention equal width? So now, can I find the width of the rectangle now? Can I find the width of the rectangle now? Okay, you tell me how to find the width of the rectangle. Oh, okay. So every time when you see question like that, you have to say, okay, you have to get the width of the rectangle first. Equal to 4 minus 0 based on the interval, divide by the number of rectangle. All right, so the width is 2 units. Yep. All right, so from 0 to 2, 2 to 4. So this will be one rectangle. This will be another rectangle. Am I right? Okay, so now this rectangle, we got talking about when you rectangle, you got the width, you must have the height. So the height of the rectangle to you will be the coordinates of VT, am I right? Can I say so? Because it depends on the point. All these points lie on the curve. Okay, so the height here, you can know the height. You can also know the height of this one and this one. So now we want to make an overestimate. So there are two heights here. So if you want to talk about overestimate, should you take the taller or the shorter one? Taller. So I draw my first rectangle. So my first rectangle, the height will be V0. Am I right? Am I right? Okay. How about my second rectangle? Okay, I also got two height here. So I also have to take the taller one because I want to make an overestimate. So the height here will take V2. Am I right? Okay, clear enough? Okay, good. Do you think this is a better approximation than 16? Definitely. Because you don't include this area. Am I right? Okay, this will be a better approximation. Okay, so now find the sum of the area of these two rectangles to make an overestimate. So that means indirectly, you have to draw upper rectangle. Am I right? Okay, so now, please take out your graphic calculator. Key in your Y1 as 2e to the power negative x plus 2. So you can write this one down in your working. Okay, you got that? So now overestimate. I will write down overestimate. Is the sum of the area of the two upper rectangles. I write this one down. In exam, you don't have to write, huh? Okay, so since all the rectangles have the same width, can I write the width outside? And multiply by the height. The first height is y10, am I right? The second height is y12, am I right? Okay, just key into the calculator and give me the answer. What do you get? 12 point something. Is it? 12 point something, correct? Is it 12 point something? Yeah, 12 point what? 54 meter in this case. So you see, so now I ask you how to use rectangles of equal width to make a better approximation. So now if I want to improve my approximation some more, so what should I do? Hey, I say use rectangles of equal width. Can someone give me the answer? Huh? Use what? Use never what? Use rectangles of narrower width. Okay, you say like that, I draw. You see whether God give you a better approximation or not. You say use rectangle with narrower width. Okay, I use you see narrower width okay. First one very narrow and narrow. Then after that the rest no. I use 3 rectangle narrower width. Can or not? Does that make a better approximation? Ha! Hey, does this make a better approximation compared to just now my that one? Huh? So, can you just say narrower width? Can you say properly for, hey, listen here. I tell you, in your SAT 3, sure got 1 mark on this. If any one of this is not right, okay, for you have to tell me the interval. You have to tell me the interval. Divide into, hey, if you want a narrower width, you just tell me more rectangles lah. More rectangles? Cannot. Because you didn't say equal width. It must be equal width. See or not? The word equal width very important. So this statement must be exactly like that. If you miss out one of it, your 1 mark gone. That is called don't chase after the mark, let the mark chase after you. You must state the interval. You must say equal width. You must say more rectangles. You don't want to give me the number, it's fine. Okay. Done, Okay, I have 4 minutes to talk about. I want to bring this to become to integration. Okay, can I? Okay, good. So now, I have this. Yeah. So this is my t. This is my V equal to 2e to the power negative t plus 2. Okay. N is the number of rectangles of equal width. Okay. So now we are going to talk about limit. As n approaches infinity. Okay, this one is for t between 0 and 4. What happened to the width? Huh? What happened to the width? Good. The width will approach 0. So therefore, the sum of the rectangles, the sum of the area of the rectangles will approach this one. So that will approach the exact total distance traveled. Are you clear? Because as the width become very small, so you are practically add up the area of a straight line. Actually, straight line, there is no area, correct? So you practically add up. So there is no space in between. Extra or less space in between. So you get the total area. So this is the sense of integration. So this sign of the integration give you the sense of the word sum. Now you know why the integration sign is look like that. It look like letter S. Isn't it? So this is the sense of limit in integration. Correct? So now, Miso also want to ask you, do you know the relationship between integration and differentiation? Okay, what is the relationship? Reverse. We don't say reverse, okay, in maths. We don't say reverse. What is the word we use in maths? Inverse. You are not reversing a car. You are doing a mathematical operation. You understand or not? When you say reverse, I just go backward. It's not. It's the inverse. Okay? So clear? So afterward, we will talk about more examples from the times that we'll talk about it. So now you understand? So the first meaning of integration is what? Summation. Sum. Hurry up. Yeah, you also can use like that. If you look at your book, they will say like that. They will write down this is the width, the summation. So it will be summation of the fx delta x.
I understand the area bounded by the curve. Y is equal to.
This is called a straight line.
Yes, this is straight line.
X equal to 0.
And then x equal to 0.
This is x, t equal to 0. T equal to 0. Y axis is t equal to 0. This t equal to 4. And x t axis, that's it. That is the name of this line.
And then t equal to 0 is in here. Right?
T equal to 0 is this line.
This time B. Oh, then it's B0. This is.
No, it's B0. Yes.
Oh,
Mm.
thank you, Miss.